Hello students, so coming back to chapter 13, that is organism and population. Here in this class, we will study about population, population density, population growth and growth model one by one, okay? So first come to population. So when we say population, we refer it as a group of organisms which are living in a particular region or particular area where the organism will compete, where the organism will share for similar resource. Not only that, here the organism will be able to interbreed among themselves. Aduna population ama hai taragdi kanano hai group of individual dune. Karamba group of individual hai kanda particular region da particular area da lagedaba. Aro hariba particular areas na moi machine compete togadabani, moi machine share togadabani, moi machine interpret togadaneba. Then it constitute a population. That means population is a group of individual. So based on this, one question can be asked, and that is, what is the difference between this population and individual? So, and this is a thing that you are going to study for exam. On a population ga individual kai khene habdo si pagadab. Now come to the point. When you come to individual, individual has sex. Habadi individual da nupa natraga nupi ogene. That means the individual can be either male or female. But when you come to population, the population has sex ratio. That is how many male and how many females are there. This is point number one. Now come to point number two. Individual, okay? Individual has birth and death. Pokpa sibalegini ko. But when you come to population, the population will have what? Birth rate and death rate. Cam po e, cam sibalakne. So this is the difference between individual and population. Next come to as distribution of a population. Here, a population at any given time will be composed of different individual, and this different individual will be of different S group. So based on this, a population can be divided into three S group. First one is what? Pre-reproductive S group. Sina represent tobogam dringi ali stage. Reproductive S group. Sina hausi represent tobdana population etoy bukangudo. And post-reproductive S group. Sina anu salabasing hana represent tobogam magasu hausi ngamzer bukangu. Okay. And if this S distribution is plotted for the population, the resulting structure is known as what? S pyramid. And this S pyramid is of three types. One is called expanding, one is called stable, and one is called declining. And we will discuss it one by one. So first come to expanding. Expanding the tikadogani hai the number of pre-reproductive S group will be more than reproductive S group. Aduna kadore in near future definitely the population will increase. So expanding S pyramid will show positive growth. Hangal amna kadoni positive growth so now come to second one, that is stable. In case of stable, in a population the number of pre-reproductive S group may be equal to the number of reproductive S group. Aduna hauzik hengaleba population siga tungda hengala population manaraneba. So the population may remain constant. Yabra stable kaure. So stable S pyramid will show zero growth. Now come to last one, that is declining. So here what happen in a population, what can happen? The number of pre-reproductive S group can be less than the number of reproductive S group. Aduna kadaroni in near future definitely the population will decrease 100 and ever. So declining S pyramid will show negative growth. So these are something about S pyramid. Next come to population density. So actually this population density, it is the measurement or number of population per unit area. And population density haitagadi given area amaduda mi kyam legi my number of population do adubugina population density hamne. That is, the total number is the most appropriate measure of population density. But in some case, it is very difficult to determine. So to understand this, let us take one simple example. Now think that in a particular area, there are around 200 grasses and a huge banyan tree, okay, covering the same area. Now from this point of view, we can say that the population density of banyan will be definitely lower than the population density of grass. But in this case, the biomass contributed by each organism is more meaningful measure of the population density. Here, the biomass contributed by this banyan tree will be definitely more than the biomass contributed by grass. So here, in this case, the biomass contribution is more important as compared to the number. Habadi, akoigi same area am lor se, same area sida nasagi 200 grass na cover to lor se. Same area duda achoba banyan trees lebiada. Population density based on number da yeng bataragadi nasagi grasses on helane. ado sista number do important oiraroi habane kana important rakane kanda ngasagi biomass contribute to habadi organic matter mo daido arna huge banyan tree na contribute biomass that is organic matter do aduna definitely more obi helane as compared to grasses na tra adu tadi sista di number do important oirak tre haba sekana important odi biomass important oirane for measuring population density. Next, come to another point. For ecological studies, if we cannot find the absolute population density also, okay, we can find the relative population density. Now, akoina ecological studies ki oina di hayeng akoina absolute density asima number do khamang amdraga su relative which saurak bhabado relative population density na samanaba magi data pigane. Retadi again to understand this, let us take one example. In a lake, we cannot count the number of fishes to study the population densities. In this case, what can we do? Here we can find the relative population density. But the question is how we will find the relative population density. So in this case, we can count the number of fishes per trap or per area. So by doing this, we can find the relative population density of fish in the lake. Okay? Aduna nasagi pukhi amada natra lake amada koi nga kyam lai koi masing count tong amrodam ko aduna koina per trap ta farakanda sumuk chawba area da nga sumuk lai pataragadi sumuk chawba area da nga sumuk lai ramgane koina relative population density do find out to yagane. And even the population can also be counted without seeing them. For example, in national park, the population of tiger is counted based on pug mark and fecal matter without seeing them. Habadi population density dokina my organism shu udana count to su yadoriba. Cry the base or kanda moiki pug mark hongun tanabado. Fecal matter when a pass out tormado to the base orga. So these are the different ways by which we can count the relative population density for ecological studies. Next come to population growth. So population of certain organism, it may increase or it may decrease. And the population say increase over y, decrease over y, and it depends on three main factors. First one is food availability, second one is predator pressure, and third one is reduced weather. Habadi and population ama hengapa hengata se karigi makha pole food ki availability makha pole neba. Food ki resource am labor jagadana masana population increase uktaba handaba jagadana population handarane. Predator pressure. For example, the population of deer will be regulated by tiger. Aitadi deer ki population se increase or decrease happen se Canada depend on predator, that is tiger depend on it. And reduce weather. That means every living organism prefer favorable climatic condition. Auna favorable climatic condition na mi se population hen be hengane. Auna climatic condition su kada we na ngasai kada population se it may increase or decrease. So these are the three factors which are responsible for increasing or decreasing the population. Next come to population density. So population density of an area may also increase or decrease, and this will depend on four basic processes. There is natality, there is birth, mortality, there is death, immigration, that is entering of people to a new country to live, and last one is immigration, that is leaving a place to live in another place or another country. Okay, so here natality and immigration, that is popaga sangzalapaga, these two are responsible for increasing the population density of an area. On other side, mortality and immigration, habadi siba natraga thokibado, these are responsible for decrease in population density of an area. Okay, now look at the equation given here. So if n is a population at time t, then you can now find the population at time t plus 1. So population at time t plus 1 will be equal to population at time t plus what? Factor for increasing the population, that is what? Natality and immigration, minus factor for decreasing the population, that is what? Mortality and immigration. So like this, we can find out the population of any species at any given time. Okay, a point for population, it may increase or decrease. It depends on three factors. Factor no, food availability, predator pressure, and reduced weather. Okay, aduga population density it may increase or it may decrease, and it will depend on another four factor, that is natality, mortality, immigration, as well as what? Immigration. Factor ani, that is what? Natality and immigration, they are responsible for increase in population density. Aduga factor ani, another two factor, that is what? Mortality and immigration, they are responsible for what? Decrease in population density. On a sig difference ani se study together. Next come to growth model. Here we will study about growth of population in relation to time. So here growth model, it will be based on the availability of food and availability of space. And based on this, the population growth can be divided into two types. One is exponential growth and another one is what? Logistic growth. And here we will discuss it one by one. First come to exponential growth. So if food and space availability for growth is unlimited, then definitely the particular species will have the ability to grow fully. Haibadi ngasai food ka space ki availability na unlimited over taragadi masana ngasai ki population ki density se yam to increase roga ayo bungam neba within a short period of time. And when this growth of a species is plotted in the form of a graph, then definitely we will get a Z-shaped graph. And such growth model is known as what? Exponential growth. Haibadi, if a population is growing exponentially under what? Unlimited resource, it may be food or it may be space, then definitely the population will reach a high population density within a short period of time. Next come to logistic growth. Here the availability of food and space for growth will be limited. Because of this, the growth of population will increase until and unless the population will reach the carrying capacity. And when this population reach the carrying capacity, definitely the population will remain constant. And when such growth is plotted in the form of a graph, definitely we will get a sigmoid or S-shaped graph. And such growth model is known as what? Logistic growth. Now, logistic growth tadi kadorni kanda food ka space ka gi availability se limited or any. Aduna population se increase to rumba taraga su magi carrying capacity mana kyam support to bungam ge habado lariba food na lariba space na kyam support to bungam ge adu yorokanda population do it will remain constant having. On high post graphically plot to taragadi we will get what? S-shaped graph. Okay. Now, Sigi growth model say we call it what? Logistic growth. Now come to one more important point. This resource, that is food and space, it cannot remain unlimited. That is, the resource will definitely become limiting sooner or later. Because of this, the logistic growth model is considered to be a more realistic one as compared to exponential growth. Aduna, so I say question which type of growth model is considered to be more realistic kind of. Logistic growth na realistic or realistic kay gino harakanda di na sabi unlimited habito for exponential growth adu lay at one stage it will become what? Limiting. My limitation na lakan. That's why logistic growth is considered to be a more realistic one. Okay. So before we wind up, let us remind what we have learned in this class. So in this class we have learned about population density, factor for increase or decrease in population, and even about growth model. Okay. So this brings me to the end of this class, and thank you very much for your attention.